The last video in this series is going to be just to clean up some of the things that you maybe missed during the other videos. They are the notes that are on the back of the note chart, or underneath, I should say, under the chart, so that they're not in the grid or not in the chart part. But they are important, and they do apply to all machines. And so I mentioned this first bullet here a number of times when I was doing the other videos, that there is always a difference between actual mechanical advantage and ideal mechanical advantage. And ideal mechanical advantage is always higher. That is because when you use any type of machine, there's always friction. Anytime there's moving parts, there's friction. And some of the work that you do, some of the effort you put into a machine is used to overcome friction, which reduces the mechanical advantage when you calculate using forces. There are things you can do to reduce that. You can add oils and greases. You can add wheels. For example, using a ramp, if you were to drag something up a ramp, there's a lot more friction between doing that. So the difference between ideal and actual would be very high. But if you could put rollers under it, it would increase or decrease the friction. And so the ideal and the actual would be closer together. Some machines have more friction, some have less, but there is always that difference between ideal and actual. Another section of the notes asks you to explain the force distance trade-off when using a machine. If you remember back to the Eureka videos, which was shown towards the very beginning of the unit, the thing that came up a number of times in those segments is what you win on the force, you lose on the distance. In other words, this bullet down here, if a machine allows you to apply less force to move an object, in other words, if it increases your force, if it makes you stronger, quotes, unquote, then you have to apply that force over a greater distance. And so if you get to apply less force, you have to apply it over a longer distance. The opposite is actually true. If a machine makes you apply more force, then you apply it over a shorter distance. And so it would be like taking the Eureka statement and flipping that around. What you win on the distance, you lose on the force. Sometimes you want the object that you're moving to move farther than your hands. And so that would be when you would use that kind of machine. Summarizing these things, I'm going to use this blank slide up here, is if you have a mechanical advantage of greater than 1, then that means that your force is increased. Ooh, I'm not going to have room here. Your force is increased, but so is the distance you apply it. So this would be what you win on the force. So I get to apply less force, but I will have to do it over a longer distance. Well, somehow my 1 disappeared here. If your mechanical advantage is less than 1, the exact opposite is true. That your distance is increased. How do I want to, undo. I don't think I want to say it that way. Your force is decreased. But so is the distance. Sorry, my handwriting is so sloppy on those. So if the mechanical advantage is greater than 1, your force is increased, but the distance you apply it is also increased. So there's that trade-off between force and distance. If your mechanical advantage is less than 1, your force is decreased, but so is the distance. And again, sometimes you want that object you're moving to move a farther distance than your hands do. What if the mechanical advantage is equal to 1? then all that is happening is that the direction of your force is changing. Sometimes it's easier to lift something up. Sometimes it's easier to pull something down. And so if all you need to do is change the direction of your force, you can use a machine that has a mechanical advantage of 1.